GeopByte.
Look at the another important problem. Look at this problem. It is asking like this. A constant torque 100 Newton meter turns a wheel of moment of inertia 300 kg meter square about an axis passing through its center. Torque tau given. Generally, torque denoted with tau, it is given 100 Newton meter. Remember, the torque unit is Newton meter because torque tau equal to, let me write it clearly, force multiplied by torque tau equal to force multiplied by perpendicular distance. Perpendicular distance. Okay. Here force is in newtons, distance is in meter. Newton meter is the unit of torque. That means torque unit, energy unit, work unit, all are remaining same, that is Newton meter. Is also written as joule. 1 Newton meter equal to 1 joule. Remember that point. 1 Newton meter equal to 1 joule. Okay. Next, mass moment of inertia given. Mass moment of inertia. Mass moment of inertia, that is generally denoted with I, equal to 300 kg meter square about an axis passing through its center. Starting from rest. Starting from rest means initial angular velocity. Initial angular velocity, I can take omega I equal to 0. Its angular velocity after 3 seconds. That means final angular velocity omega f equal to how much? After time t equal to 3 seconds. That is the question. Okay. For that, as you know, torque tau equal to I alpha. Alpha be the angular acceleration. From this angular acceleration, alpha equal to torque divided by I. What is the torque given? Look at the torque 100. I given 300. 100 by 300. 100 by 300. It is equal to 1 by 3 radians per second square. Radians per second square is the unit of angular acceleration. Okay. Then the final angular velocity, final angular velocity omega f equal to omega I plus alpha t. Alpha t. Omega I equal to 0. 0 plus alpha we got 1 by 3 time equal to 3. Finally it is equal to 3 3 cancelling 1 radians per second. That is the final angular velocity after time t equal to 3 seconds. Look at the options. Look at the options. Option C is absolutely correct. Understood clearly? Yes. Then let us take the another important problem. Look at this problem. It is asking like this. A bullet is fired from a gun at the speed of 280 meter per second in the direction 30 degrees above the horizontal. That means initial velocity of the bullet. Let that initial velocity u equal to 280 meter per second and angular projection let it be theta 30 degrees to the horizontal. Maximum height attained, here g value given, acceleration due to gravity g equal to 9.8 meter per second square, given that sine 30 degrees equal to 0.5, that is equal to 1 by 2, that we know it. You know, maximum height maximum height attained by the bullet h max formula u square sin square theta by 2g. This is the formula. U equal to 280, 280 square into sin 30 given sin square 30 divided by 2 into 9.8. This is equal to 280 into 280 into sin 30 given zero point 0.5 whole square divided by 2 into 9.8. You simplify this value for getting 1000 meters. That is the maximum height attained by the bullet. Understood clearly? Look at the option D. Option D is absolutely correct. Understood? Yes. Similarly, look at the almost similar problem. Almost similar problem. From this, the conclusion is in the NEET, there is a chance to repeat the similar question. Okay? It is asking like this. Instead of a bullet, it is given cricket ball. A cricket ball is thrown by a player at a speed of 20 meter per second in the direction 30 degrees above the horizontal. That means initial speed of the cricket ball u equal to 20 meter per second. Angle of projection, let that angle of projection is theta, given 30 degrees, the maximum height attained. Here g equal to 10 meter per second square. Here sin theta value is not given. As you know, maximum height h max, just now we have discussed the formula, u square sin square theta divided by 2g, u is 20 square into sin square 30 divided by 2 into 10. Simplify this value. It is 20 into 20 sin 30 1 by 2. Then sin square 30 1 by 4 divided by 20. This 20 20 cancel. 4 5 times. Therefore maximum height attained is 5 meters. Look at the option A. Option A is absolutely correct. Understood clearly? Right? This problem and the previous problem almost similar, only the speed is different. Okay? Yes. Similarly, let us take the another important problem. Okay? Look at the screen. It is asking like this. A ball is projected with a velocity 10 meter per second at an angle 60 degrees with the vertical, not with the horizontal. Let us take the horizontal direction that I am calling as ground, and this is the vertical direction from the point A. It is given that ball is projecting with a velocity u equal to 10 meter per second at an angle 60 degrees with the vertical. Okay, then what about the angle with respect to horizontal? It is 30 degrees. Then it can maintain the projectile motion. The projectile motion may be from A to B. Let the C be the highest point. C be the highest point. C equal to highest point. Okay. Then what he is asking, its speed at the highest point of its trajectory will be. At the highest point, what is the speed? Remember, at the highest point, at the highest point, vertical component of velocity, vertical component of velocity equal to 0, and horizontal component of velocity, it is remaining constant throughout the trajectory path. Horizontal component of velocity equal to u cos theta. This theta should be taken with respect to horizontal. It is equal to u 10 cos 30. Cos 30 equal to root 3 by 2. Therefore, it is equal to 10 root 3 by 2. It is equal to 5 root 3. 5 root 3 be the horizontal component of velocity at the highest point. Therefore, option A is absolutely correct. Okay. Dear friends, remember cos 30 degrees equal to root 3 by 2, whereas sin 30 equal to 1 by 2, whereas sin 60 equal to root 3 by 2, root 3 by 2, cos 30 equal to 1, cos 60 equal to 1 by 2. Try to remember these values. Okay.
GeopByte.